And that Ron was talking about this procedure in length. So this is current procedure, how to determine compliance of mobile phones with safety. So the mobile phone is placed below the phantom. The head shape has to be designed to be conservative, as well as the liquid parameter. Now this is the measurement tools to verify the simulation. On the simulation tools, in the late 70s, when I was studying, this was the sexiest thing one could model. Then in the late 90s, it was possible to model a phone as it comes from the drawboard of the engineers without simplifications. But that took at least 20 hours on a supercomputer. Nowadays, we can model much faster. We can model 3,500 voxels per second, which brings us down for a mobile phone with such complicated head model to 4 minutes, which results in that we can model much larger spaces. We can model base station in cities and how it affects the mobile phone, which we held in our hands within the cities. So this is modelable, or the effect of small implants in the body in this complex field. So all this became possible, as well as also the hand manufacturers relying more and more on simulation tools, actually designing the phones using such tools. But if you look at the number of people you have to look at, and the different posture you have to look at to come up with a good assessment, it still takes a lot of permutation, though there's still a need for higher speed, for higher performance in simulations. So what kind of uncertainty we can account for? In simulation, typical relative uncertainties are in the range of 5%. Typical absolute uncertainties in measurements are in the range of 25%. Now if you combine it, then you're in the range of 30% if the source is well known. And if you try to assess with a lot of permutations, and you want to assess the exposure of a certain percentile of the exposure, then you're ending up with a factor of 2 when you're lucky, or higher. So I want to quickly talk about what are the latest important dosimetric findings. Back to mobile phones. The exposure is below whole body safety limits. Sound compliance testing of peak spatial SAR is valid for adults and children, as we do today. As you heard, Om and I disagree on this point. However, what we agree is that the cortex exposure of children is in average higher. So this shows an animation of a phone next to the ears of an adult and of children. And why is it the exposure is higher? Simple, because as you can see, the phone, due to anatomical reasons, because children have a much shorter face, the phone is getting much closer to the cortex than in adults. And that's why in average children have an exposure which is about twice the exposure of adults. The exposure, if you look not in peak spatial exposure which occur anywhere in the head, but if you look at specific exposure, which we need to look at if you look at non-thermal effect, can strongly vary from phone to phone depending on the system. So this can be a factor of 1,000 or more. We also looked at the Pinna. So we measured Pinna. We developed a device to measure the Pinna of adults and children. And you can see from this distribution, so to our big surprise, the Pinna differences is not as great as we would expect it. We would have expected much softer ears for children, which causes a lower thickness of the compressed pinna. We looked then also at the SAR, and in our study we could show that even due to the distribution, comparing to SAM, the real exposure is always lower than what we found in adults using this sophisticated children models, with also the appropriate dialectic parameters which are slightly higher for children than for adults. We also found that the skull marrow exposure of children is significantly higher, a factor of 10 or more. And as already mentioned, the exposure is strongly phone design dependent, a factor of 1,000 or more, depending on the phone and system to be used.